Welcome to the lecture series on real analysis. In the previous lecture, we have seen some relative openness, right? Now we are going to see some examples of finding the neighborhood in the submetric spaces. Here, we are asked to find out the neighborhood of 1, 1 in R2 with radius 1. Now, I am not going to find out this thing in a detailed manner because we have done these kind of examples in the previous lectures. If you have any if you need any clarification, you can just go and watch that lecture. The link is given in the description as well for your reference, and directly let me draw. Okay, we shall visualize these things, right? So let us consider this to be our R2, okay, in which this is going to be the point 1, 1, right? And the radius is given to be 1. So I will have a circle. Actually, I will have a circle because the metric is given to be the standard Euclidean metric. I am just going to get a circle of radius 1. Excuse me for the bad diagram. Okay, I am going to get a circle of radius 1. So this is what I am getting actually, right? So this is the neighborhood of this point 1, 1 with radius 1 when it is treated in this entire R2. Now when I restrict this to 0, 1.5, which means the 1.5 point is going to lie here, right? So this is 0, 1.5 cross 0, 1.5 and the boundary included. Here, while constructing these things, I am not including the boundary, I am just including the interior points because we are talking about the neighborhood, right? So this is going to be 0, 1.5, this interval with this thing. So the common area is going to be what? This part. Now if you need to find out the neighborhood of the point with the same radius in this, okay, now this is the subspace that is given to you, okay, in the entire plane, this red colored one, okay, this is your subspace, okay, with the same metric. This also forms a metric space that you can check if you want. Now what is the neighborhood of this point? This point is inside this metric space, right? And what is going to be the neighborhood here? So this boundary, the boundary inside this circle is included, the boundary, okay, actually this part is included, this part is not included, therefore this part is going to be your neighborhood. When this point is treated as a member in this subspace, okay, so this is going to be, the shaded region is going to be your neighborhood, right? Now it is also given that in 0, 1 to 0, 1, so you are restricting your space to this thing, okay, the entire boundary is included in your submetric space, right? Actually the first case that we have done is this is the first case that we have done, okay. Now we are doing for this case, right? Here in this corner only, this is also included. Here is your center and you are asked to find out the neighborhood of this thing with this radius. This is going to be what? This is going to be only this region, okay. Here the boundary is excluded, these boundaries are included, because when you actually find the neighborhood in the entire R2, what you are getting is this entire circle. But whenever you restrict, that is you find the neighborhood of this point in the submetric space, your diagram is slightly differing, right? So this might have given you the idea of how the neighborhood takes shapes are takes place in the submetric spaces, right? Whenever you consider the sets in a whole sense, that is entire R2, R3, entire R, like that, your center exactly lies in the center, right? But when you start restricting the things, your center is not exactly, okay, this was your neighborhood, right? This is some unshaped region. Here you cannot exactly say this is my center point, but here we are fixing this as the center and trying to find out the points. This actually covers the entire circle, but out of this circle these points are included in my submetric space. That is why we are collecting those things alone, right? So in the previous lecture we have said about the openness, okay, that is the relative openness. Some of us may have a question that do we have something called relative closed? Yes, of course we do have. Suppose this is going to be the case, okay, something may be a limit point here, may not be a limit point here. Something may be a limit point here, may not be here. That depends, right? In that case, we will have to check whether all the limit points of this set under this space is in E or not. Okay, we'll have to check those things as well, right? So just like we have relative open, we have relative closed too. Based on that, we will see in the upcoming lectures. If you have any queries in this lecture, you can post it in the comment section. That will be clarified within 24 hours of time. Thank you for watching.